Good evening, everyone. I hope you are doing well. I'm Chanita Pereira and I'll be your moderator for this evening. On behalf of the Slate First community, I warmly welcome you all to today's session, Go 101. We are really excited to have you here today as we dive into the fundamentals of one of the fastest growing programming languages in the tech industry, Go. Whether you are completely new to Go or just curious about how it works, this session is designed to give you a solid starting point. Today, we'll get an introduction to what Go is and why it's gaining so much popularity and where it is used in real world applications. And also, you'll get a hands on experience on it. So, by the end of this session, you'll have a clear understanding of why Go is considered as a powerful and efficient language for modern development. Now, it's my pleasure to introduce our speaker for today. We have Mr. Sithum Bopitiya, who is currently working as a software engineer at qlub. He brings valuable industry experience and practical insights into modern software development, and we are really excited to learn from him today. Thank you so much for joining with us, Mr. Sithum. Without further delay, I'd like to hand over the session to Mr. Sithum. Over to you.
Hello, hi all. As she said, my name is Sithum, and I hope you guys see my screen clearly, and I hope you guys can hear me. If you can't hear me, just let me know. Otherwise, it's okay. And then before the beginning, thanks for joining for today's session, and I will try to prestige the like at least give introduction, give heads up, do some push to start the go as I could, and then I'm try to teach you for the like what's the basic, how it's work, and then why you should pick sort of thing. And yeah, so but first of all, like if you are already know a language, right? If you already know a language, or if you are working somewhere, if you are associate engineer, ATL, TL, this is not for you, right? Because this is not for you, but this is session for the student who not yet able to pick any language yet, right? Uh, right. So I think before that I will share my GitLab repo here. I think I can post it on the chat. Let's see. Right. So this is my GitLab repo. You guys can go and check. Right. So this session mainly for the students who are not yet able to pick a language, right? Students who are struggling to pick a language. That's my today goal. So I'm just trying to introduce you guys to Go, and because Go is a very simple, easy to pick language, and then widely spread language, and this will be very easy to deal with. So if you have any friend, anyone who's struggling with speaking language, or you guys thinking like, okay, I am had to do this project research, or maybe next semester project, or even for this current semester, if you have any project, if you are working with the team and then you guys have a issue to pick a language, try to figure out language, right? Go is the best language for you, right? Because it don't take that while to learn or understand, right? If you already know language, then definitely you can learn this, right? So if you have anyone who not yet able to pick a language, just please join. I will try to go you to this, right? So I will give a maybe the next couple of minutes, like a 2-3 minutes, I will give you the explain the Go history and the Go things, and then you can learn it. Then I start session. So you guys have a couple of minutes if you guys want to tell anyone else to come and join to the session, right? So first of all, this there is a the repo I share with you, right? You guys go and check, right? So it has the slide on here, right? Is explain how you have to uh, go. I told you guys to install the Go before the session, right? If you are not install the Go, you can go to the go.dev, right? And then you can install the Go from here, right? I'm not going to cover that part today, right? So you guys have to go and install the Go, and I hope you guys familiar with the G2, right? So you can download and install from here, uh, and yes, you guys can hear, you can see, and then you can just play the slide. It will be run as a normal one, and then you can go to site folder, and then in here there's a to do folder, right? Mini project for to do, right? So this is the one. So is the project. So if you got bored, or if you already know Go, if you guys want to try, right, you can go and try the to try to do this to do, right? It's keep this some comment and out these things, right? You can try with yourself, right? Nothing special. You can try with this special this one. If I have time, if I have time before I finish this, I will try to do this. Otherwise, let's leave it to you guys to done it, right? So again, this is for the students who are not yet able to pick a language, right? If you have anyone, just come, tell them to come and just join the session. Today I will explain the whole the thing. Okay, right? So let's start session, right? So so before we start, I will tell my name is Sithum, right? So you can call Sithum Bopitiya, right? Right. So you can find me on Sithum online. So this is my handle, right? Handle, right? So you can find me on any platform you want to like a Facebook, Instagram, I don't know, maybe TikTok or whatever, right? And then you can find my website also, uh, right? So this is my website. So you can go and then see there's not depends on just links, right? So okay, let's get into the slide, right? So the first couple of ones will be a little bit boring, right? Because I will give you guys time to the join and then talk to other friends to come and join. Okay. So so let's start from the why does Go exist, right? So in 2007, right, there was in the Google, right, there was a legendary developers work on the some C++ code base in the Go in Google, right? They had to do a small change, right? And then it took a 45 minutes to get compiled, right? And then there was a one developer, one engineer called Robert Pike, right? So Robert Pike, you can Google it later, right? So Robert Pike is the one who created the Unicode, and then he is the one who created the Plan 9, right? So Robert Pike, so thanks to Robert Pike, you guys have emojis today. So basically, if you are using emoji today, he's the one created the emojis, basically, right? So he joined to the C++ 11 session and introduced 35 new features, right? Already by the time that C++ have plenty of new features, it don't needed any features. So the problem was what's wrong with the C++, and then they got some whiteboard and then they write down what they want. If you build a new language, what they want, right? So then they write a full of whiteboard things, and then there was Robert Gesheimer and the Ken Thompson, right? So Ken Thompson is the co-author of the Unix OS, right, and then the co-author of the C. So so he also there, right? So they work together and then they make it, and then it built in Go 2007, and then the open source 2009, and then released the 1.0 in 12, and then it has a backward compatibility till today, right? So what's this backward compatibility mean, right? So the game change of the Go is if you can read the Go today, right? You can read any code in the past, right, or the future, right? If you know Go today, it will barely change, right? Like no any fancy keyword, no any fancy fancy, like annotations, no fancy marks, nothing, fancy symbols, nothing. If you learn it today, you can do it forever. You don't have to learn it again, no, nothing. If you learn it, if you master it, that's it. For next 20, 30 years, you just learn it, that's it. You don't have to relearn anything or study anything. So if you are a university student today, right, try to pick a goal today, right? If you manage to pick the learn language today, you will be able to either do it for like you can read all the code written in past and you can learn it for the future, right? Because it's not going to change in the future, right? So that's why I told you guys before we start, tell anyone who not able to pick the any language, right? So what is go out of the box fix, right? Compared to C++, fast, but is unsafe, complex. C is not complex, C++ is complex, very so very slow compilation, and then memory management, like manual memory management. When it comes to Java and C Sharp, safe but verbose, and the heavy runtime, slow startup, right? And then took a lot of memory. If you are ever run any Java program or anything written in Java, you will face this, right? The is a heavy runtime. Is when you open it on your machine, you feel your machine get hot, right? And then it takes a very long time to get it started, and it will basically eat your run, right? So that's the killer thing for the Java. And then for the Python, Ruby, JavaScript, so issue with that is yes, it's friendly, but for my opinion, the most friendly one is Ruby. I don't know if you guys ever try, but Ruby is much friendly compared to Python. Even Python try to be so friendly. Uh, but the thing is, the Python and Ruby and JavaScript is very slow, right? And then but and then it's really weak in concurrency. And then other thing is this concurrence is very hard, and then dependency manager is very painful, right? If you ever work with the Python, you definitely face that issue, right? If you are working with Python, this dependency depend on that dependency, depend on that dependency. If you change one, it will be falling for the others, right? So is this Go don't have that issue, right? It's mostly just work out of the box, right? So basically, Go is fast as C, right? Safe as Java, and then simple like Python with the concurrency building, basically, right? So compiling second, and then for the one single binary, no Java, no runtime, no JVM, right? And then Go and channel build out, and then garbage collected, right? So this is the Go family tree, and then we have a Europe branch, we have American branch, and then they took some inspiration from those two language and built the Go. So and then Go, most of the features in Go is written in 1970, right? So it's not a really new features, though all are get it from the old languages. I think you guys can read it. I'm just skipping it. Uh, so what is Go, right? So I think every file is belong to the package. Main package special, main is always right. So let's start, right? So I'm going to start it from here, right? So try to pay your attention, right? I just try to explain you guys since a very basic, right? So I hope you guys can get it right. So if you just pay the attention and do it right, I hope everyone joined this session, right? So let me start. Uh, I hope my battery will not die. Okay, so let's go ahead and notation. Okay, I think I got my presentation, right? So, so I'm going to annotate the screenshot and then explain you, right? So try to get this, right? And then if you face any issue, you can add the comment, right? And then I think Sayuru can post the poll here, right? The favorite languages, this poll, right? So if you guys can put your what you guys want, right? I think Sayuru can poll the please send the poll. Okay, so let's start, right? So basically, so right. So just imagine, right? Every Go file belongs to the package. Every Go file belongs to the package, right? So every Go file is starting from the package name, right? We start from the package keyword and the name of the package, right? Name of the package, right? And this is the import, right? So we start from the main, right? This is the key entry point, right? This is the entry point, and then we start going to the up to down, right? I hope it clear. I will repeat again, right? Every Go file belongs to the package, right? Starting from this keyword, package main, package to do, package API, package handler, whatever, right? And then this is the package keyword and the name, and then this is how we import. And the entry point is main, right? Main function is the entry point. Okay. I hope it's clear. Okay. Okay. Hmm, go ahead, close this. Hmm, So if we go to the next one, right? So the functions, right? So the function, right? So when it comes to the functions, I'm just explaining with the one by one, simply, right? So the functions just we use the func keyword. For the functions, we use func keyword, right? func func keyword for the function. We don't write the function's full name, right? Or fn or def, right? We just use the func, right? And then we write the name of the function, right? And then we tell the what the variable is going to in A, B, or C, and then we define the what's the data type, right? I hope you guys clear. Func keyword, name of the function, right? And the what is the name of the variable, data type, and then the return type. Return type could be one, or if it is a multiple return type, you can do right like this, right? Okay. What is has func keyword, name, right? And the within bracket was the parameter name and type of the parameter and return type, right? That's it. Simple, right? Okay. I have to close it. Hmm. Okay. Now we go to the data type, how we store data, but how do we declare the thing, right? So basically here, right? So right. So for the variable declaration, we have mainly two methods, right? One is we can simply declare variables like this, right? We can just name and things, and then we can declare a variable without initialization like var age. We can just declare this like this as a without a sign in value. We can declare an unassigned variable's name, right? So these are the basic types. We have a int, we have float, you know, right? The float type, right? This type. We have a boolean, true or false, and then we have a string, right? Clear, right? We have two types, right? Can just You can just type this, right? We have two ways to declare variables. Two ways. One is var, name of the variable, type, right? Var, name of the variable and type, right? Or you can just simply declare like this way, right? Just whatever name you want, right? Let's say, uh, I don't know, like maybe type. No, we can use type. We can just name label, right? We can just colon equal and then whatever you want, right? Simple, right? 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 Nothing fancy. Again, this type or this shape, right? These are the only two ways, right? Just these are two ways, right? Okay, so, and one another feature has Go is Go is have a another feature Go has is Go is a zero value. We call zero initiative or something, right? So what is this is if you declare a variable, right, whatever variable, it has a default value, right? If it is an int, it's a zero. If it is a float, 0.0, bool, false, and then string is empty string, right? That's it, right? Every value has a default value, right? So because of that, it will not get panic, right? It will not get panic or it will not get undefined or undefined, right? In unlike the JavaScript, it will not be a undefined, right? That's not going to happen in Go, right? It's always has a value, and it will not going to panic because of its undefined. So you don't have to worry about it. Just keep it in mind. If you want, you can just check. If you want to check is that value has a set of value, you can just simply check if and check it as a value. That's it, right? Okay, we have const, right? We have const two. Who has a const two, right? And then nothing fancy. Just define as a const. That's it. Just const, and then the name of the variable and the value of the variable. That's it. Right? If you want to const, you can define like that. So if you come to the loop, right? Go don't have 100 different loops. Go only have a for loop, right? Just for loop only, right? Like like for I do while, like like for each, right? Or for in, no, go don't have those things. Go only have one loop, just for loop, right? There's all the four types. Go have one single variable for loop. That's it, right? You can just like classic variable declaration. You can do like this, or you can just do like this, right? That's it. Nothing fancy. Just for loop, right? And then this is a switch statement. Simple, no break, just simple, right? Uh, okay. So this one is the main keyword, right? The structures, right? So when we come to the structures, right? You have to define type, whatever the name of the structure, right? And then you can define your field, right? So in here, if you put a first letter capital, it means you will export it or you can access it public. You make that field public, right? If you make it simple, right? If you write a name, right, in simple letters, just first N is simple, then it will be a private. That's it, right? So that's how you define the make it a public or a private, right? So the type, name, and then whatever structure you want, right? That's it, right? You can just simply just define the structure, right? So maybe you can consider this is like if you didn't work with to this kind of language, you can say it's a basically class sort of a thing, right? Not exactly class, but it's basically class sort of a thing. So we have a if you want to make the name public, you can make it in capital. If you want to make it private, you can just simply say name and then you can make it the private. That's it, right? No public keyword or no private keyword, right? We don't have that. We just basically put a name is a capital or a simple. That's it. If you make it capital, it will be a public. If you make a simple, it will private. That's it. No any comma, nothing. You can just define the structure, right? You can simply define the structure and you can simply set the values you want. You can just simply like call each one address by name. Or you can call it like if you use in JavaScript, you can call it like a object. Same thing, right? It's a class or object, right? You can just simply call from dot notation, right? That's you all have to do, right? Just put a you just get the one initiate with then call, right? If you didn't put a value, if you didn't initiate the value, no problem. It will be return the default value. That is not gonna just break it, right? If you want to iterate, like if you declare like a variable, if you declare an array, I will go for the array. You can just simply loop through it. Let's talk it array section. For now, it's good. I hope it's clear for you guys for now. This is structure labeling, and so how do we store the value? So we have so we can say like we have a map, and then we have an array and slide. You can say is if you are familiar with array, let's say array. Like you can say whatever you want. You can say whatever you want. Basically, array has a fixed size. Slice is a dynamic. That's it. Like you can say like you can don't care about the word is a slide to array. If you are with familiar with array, you can say it's array. Let's say it's array, right? Don't think it's a slide to array. Just simply think go only have two type, right? Array and map. That's it, right? It's that simple, right? It's only have two types, arrays and maps, right? Just array mean array, just array. Map mean map, just map, right? That's it, right? Arrays and maps. Just those two are the data type it has, right? Like no any fancy data classes or like in Python we have data classes, weird things. In Go we don't have those kind of data classes, data objects. We don't have those things like a generic like string, comma, string is string. No, if you're working with this kind of a language, like you're working with Java, and then you can't just, oh my God, there are so many complex generic. I can't understand. In Go, we don't have those kind of things. We only have arrays and maps only. That's it. So let me the annotation again. Okay. What to do? See slides. This one will be clear. So it will be like uh, dead simple, right? As I explained you before, you can define the structure here, right? Just the student name and his score, right? So if you're defining array, you can just define like this, right? And you can just put a fixed side. But if you don't want, like if you don't care, you can just simply define like this, right? Like nothing fancy. You can just simply just student array and then just declare it. That's it. Like no any fancy keyword. You can just simply do that. And then if you want to add the new student for the existing student array, you can just append the whatever variable name you want, like whatever array or what want. You can just add the structure you want. That's it. Like very simple, right? So that's why I'm saying you guys to like if you're struggling with any language, just come and join this session. You can just easily pick this, right? So again, like if you can just define the fixed size and do it, or you can just do it like this, right? Still work, right? And then there are few different ways we can explain. Let's see. Uh, okay, right? Don't have like to think, okay, like we have to do a make. No any fancy key. I think this keyword, this safe will explain you guys like nothing fancy, just you can simple do that. Uh, okay, so this is how size work. I think that you don't want. So this is the range, right? So this is the range, like how do we iterate over array? This is showing like how do we iterate over array, right? Like you can just define the array and you can just range over the array, right? Like this is the number, right? And then this is the object, right? This is the array, right? So if you make a like array array of object, right? If you make array of objects, right? You can simply iterate, right? You can just get the first, you can get a number, you can get the object. Uh, that's it, right? Simple. Uh, I hope it will clear, right? Like simple, you can iterate, right? This is how you iterate structures, that you can call it object array, right? If you are familiar with the Java or from the JavaScript, right? You can just object array, and then maps. That one is not clear. So the maps, right? So when you come into the maps, right, you can basically define like this, right? You can just simply use the map keyword, and then what's type you will as a we can call the key type, right? And then the value type, right? Simple, right? What type you will use as the key, put the bracket. What's the type you will as a key, and then what will be the value type, right? That's it. Map. What is the key type, and then what is the value type, right? That's it. Like you don't have to put a generic keyword or something, right? You don't have to put a like TypeScript or C Sharp or Java. You don't have to put any type of the fancy annotation, no fancy things, right? You can just don't have to put a bracket, like code, brackets, whatever thing. You don't have to, right? This is simple, and then this is the key type. These are how do we define the key, and these are the value keys and values, right? Simple, right? So this is the like right, their record, right? So this is the student, and their record, right? Student record, right? And then if we want to see is is that that map has that key, right? Like you define the posters, right? You can just simply define the key, check the is that key is available, right? So if that key is available, this is the value. This will be the bool, right? So it will be true if that key is available. If not, it will be false, right? Simple, right? This is the map, right? And then this is the map name, and this is the key, right? This is the bool like it says, is that available or not? Right? This bool is available or not, right? This is the value. That's it. It's simple. You can just look like that. Okay, let's go for the next one, and then yeah, we have pointers, right? This is simple pointers. We have a pointers here, right? Like if you don't want to waste your memory, you can use the pointers. But I think I'm not gonna cover it. Right? If you guys want, you can read this and understand it later. That I'm just going to skip that part, right? And this is how pointers is really working. I don't care. You can learn it later if you have learned the pointers. Uh, yes. What else? We have interface. How we handle this? Okay. So let's go with this, right? So how we do that? So this could be a bit new, right? Not fully new, but could be a bit new, right? If you didn't work with the class, this type of language, right? So in here, in the Go, as I said, you can define the structure, right? And then you can define the we call the structured embedded functions, right? This is like embedded functions. We call this structure embedding, right? We call it structure embedding, right? Basically, you can if you work with any other language or any other thing, right? You can just simply do like uh, so. If you work with the any other language or any other C plus like class-based language, right? So if you work with the any class-based languages, you can simply do right. Like if you got a class, right? So class has a methods, right? Right. If you work with any classes, right? Like if you work with the Java or something, right? Classes has a method, right? So this is how we do it in the Go, right? Basically, in rectangle structure, we have these ones, right? So what you have to do is, right, you can just embed these methods to with that structure, right? Embedded the method into this structure, right? So when you set the value, I mean you don't have necessarily set the value, but after you set the values, or you can use without setting value as well because it will not get panic, right? Because it has a default value. But if you didn't set a value, it will have default values, right? But if you set the values, you can simply call these functions, right? Basically, in the other languages also, if you have a classes, right? If you have a classes, you can just make a new maybe car and then the parameters, right? So whatever thing, right? So in the Go also you can do the same thing, right? You can get a structure, set the parameters like this, right? And then you can call the methods. Simple, you can call the methods, right? So that's also that's my control, right? So if you want to make it public, make it capital, right? If you want to make it private, right, make it simple, right? That's it. Uppercase, lowercase, right? If you want to make a method public, make it capital. If you want to make it private, make it simple, right? Just the first letter of the function, right? The way you define, like you make it uppercase or make it lowercase, that's how it will define. It will be a X word or not, right? So I hope it will very clear, right? Like it's don't have like you don't have to define a big class and then you can don't have define the private function or public function or you don't have to like don't don't even have to define those functions. It is simply like just very simple. You can just simply make it capital uppercase and then if you want to add a new function to the existing structure or maybe the class, right? You all have to do it. It's right, write this, right? Write function, the what bracket, the method you want to structure, and the name of the parameter. Clearly, right? Just basically uh, name of the structure you want to embed that particular function, and then the variable name, right? You can call it R, you can call it RB, ABC, whatever name you want, and then the name of the structure, right? That's it. You can just simply address it like this, right? It's basically like you are calling how you call in uh, function parameters, right? Just basically how you call it like this, right? The pretty normal thing, right? You can just write like area. You can write area, and you can write x int, y int, and then return bool comma string. Right? You can just write it like that, right? Just one context, you can just write define all the things. Okay, let's go for the next. Uh, so the interface. Interfaces. Let's see. That's the interface here. So for the interfaces, right? So it just is a classic example. So the like again like every other interfaces, right? Just simply we use we use structure type before. Now we use interface type. Just basically the signature of the function, right? Name of the function, right? And then what are input parameters, and then what is the return type or types, right? That's it, right? Interface, right? And in here you can define the name of the function and then the return type, right? That's it, right? So this is how you define the structure, right? And then uh, you can just simply define like two classes maybe, right? Like this is for the circle and then this is for the rectangle, right? So you can just basically implement this same method, this structure, right? The same method, this structure here, right? Same method, this structure here and here, right? Simple, right? I hope it's clear, right? Just just same structure, area and the type, the whole thing you can just simply structure the same thing, right? Then you can define how you want, right? Max or try or something or right? Just do the implementation, right? And then you can just simply like you can call from the interface, right? Then just pass this stuff simply as this, right? You can just interface is just another type basically, right? You can just pass the interface name and then it can call it, right? You can just simply uh, print print area. You can just circle, rectangle, whatever the type you want. It will work. That's it. Simple, right? I hope it clear so far, right? Because I'm just come here with the what I explained you guys so far, right? Same thing. I just came for the point to point. I hope you guys get it what I said, right? So the basically this interface, right? And then this is the structure we talked previously, right? And then these are the types, right? These are the, like the name. This is the data type, right? Variable name, data type, right? And then you can just define the interface, right? Whatever the functions you want from here, right? And then you can just run it, and then you can just like set the variables and then run it, right? It will work. Okay. This is I think you guys can just read it and then get understanding how this works. And then yes. So the other thing, how the go do the error handling, right? So the one problems like everyone face in here, like in other languages, like how do I do the error handling, right? Like 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 if you guys working with the Python, Java, like JavaScript, uh, Python, Java, JavaScript, what else? Uh, yeah, what JS, TypeScript, right? Whatever. How do you guys do that? You just try and catch, right? You just try and catch, right? You don't know where the error happened. You just can put it for the 100 line. You can put it to the 1,000 line. You don't know where that happened. But in Go, right? It's simple, right? Error is just just another type, right? For Go, the error is just another type, right? Just type you return from a function, right? It could not necessarily be a function, right? It could be interface or whatever, right? It's just another type, right? So you can just return it from a function, right? Simple, you can just return it from a function, right? Right. So if you like get this function we are returning error, you can retrieve as a basic variable, right? You can assign whatever you can say e, you can say you can say r, whatever you can just get it, right? And then you can check is that error is a null, right? Or null or nil, or you can whatever you can call null or nil or whatever, right? You can basically get the error. Check is that nil, right? Just basically check, put if condition and check is that a nil, right? Check is that variable is there. If it is error, in here what we do is we just can handle it, right? You can just simply handle it, right? And you can just return it. That's it, right? Simple, right? It's simple, like no try catch, no exceptions, exception type in, exception generic. There's main function to handle all the generic. all the exception class, error classes. We don't have that. We don't have, right? It's just the error. It's just a simple thing, right? Simple error. The simple type. It's just the error type. That's it. You just return it. You can just declare as a variable and put if condition and check is that error is null or not. If it is not a null, then you can handle it. You can print it, you can return it, you can modify it, you can change the variables, you can try again, whatever. Right? That's it. Or you can forget about, you can just return underscore if you don't care about error, then just go. And then go with your life. Right? Without thinking about it, you can just put underscore and then just forget about it. Then just move forward. Right? That's it. Uh, so we have Go routines here, so I'm not going to explain the Go routines today. Uh, I'm not going to explain this for you guys today, right? I think I just did more than 45 minutes. And then Go has a test, Go have built-in test. You don't need the third-party dependencies, right? You can just use the Go test built-in library. I'm not going to do that either today, right? I just skip it. Yes. And then, like, if you guys work with the OOP. I know you guys learned OOP in the uni, right? I'm not sure you guys did it today, right? But I don't know you guys did it like for now you did it, but like maybe I don't know. I don't remember which year it got teach. Maybe third year, second year. I don't know whatever year, right? So this is basic map, right? So for the classes, we can just get the structures plus method, and if you're going to new pool, you can just simply right? So this is this all self, right? We don't do the self for this. We can just basically put like this, right? Nothing fancy. If you remember the previous structure, right? You can just so in here you can just func s student and then maybe the age, right? And then int sort of a thing, right? So this is what we're talking about here, right? So this is the new who we don't have new we don't have the new anyone. You can just say student and then declare name, age, whatever you want, right? That's it. Uh, we don't have necessarily like we don't have like inheritance basically. We have composition. Basically composition when we don't use inheritance. We just composition, right? And then abstract class, interfaces, file speed, lowercase name, public capital, right? Throw the error, we don't throw errors, we just return the error value. That's it. You can just if you want to use the setup, you can just use this one. But you don't have to use this because we have this stronger, you don't have this one. Uh, I think this one this one is may help you if you already know Go. If you already know OOP, sorry. If you already know OOP, this one will be definitely help you. But just simply map because this is not necessarily OOP language, right? You can just map it whatever way you want. Right? This is like more like but the name is not oh object on the language, right? You can just we don't fully focus that we don't have those fancy keyword anyway. So it's a to-do list. So we come here. So Go only have 25 keywords, right? Just 25 keywords, right? Like the Java has around 2 times more, right? and then the C++ has 4 times more, right? Just go ahead 25 keyword, right? That's it, right? You can just simply pick it, right? Like if you are thinking, oh my god, Java so hard, I have to learn the Java, so much things, interfaces, public classes, I can't understand public interface. But in Go, it's nothing like that. I just 285 keyword, right? So like I teach you guys, right? All I learn, right? And then this one has a pretty much everything. Like I think this one has pretty much everything, right? So like uh, so this is 25 keyword. I'm guarantee you, right? Because like what I teach from today, from you guys, right? You can just simply read the 80% of Go code, right? You can just work with the 80% of Go code bases, right? You can just simply work with simple work, right? I guarantee you, right? Just what you learn from you can just do the 80% of work, right? Like I just skip you Go routines, right? And Go routines channels. I skip that part for you, right? And then testing, right? And then Go recently have generic as well, right? Generics as well. I skip those parts, right? Because this is not no need for the 101, right? All right. So this one is fair enough for the 80%, right? And then you can simply like do like my to do project which I hold on. Uh, you can just simply do this my to do project, right? With what you got learned today, right? Like simply learn it. Simple you can do it, right? This is it, right? I don't know guys can believe, right? Right. So I don't know you guys can believe, but this is it. Right? We just took it in 1 hour, maybe. This is it. We done, right? This is it. That's all for the Go. That basically that's all for the whole language, right? That's all for the whole language. Like maybe you can believe me or not, right? So if you guys don't believe, right, you can just go and read the code, right? Simply, but that's it, right? This is it, right? This is packages, import, store data, variable, constant, basic types, if so it's right. That's it. The standard library, right? So this is I think this on my slide. If you go to my GitLab and then you should be able to see these things at the end. Yeah, in here you can see this one has all the standard libraries and everything, right? Everything you want to like if you want to further study or further understand, right? That's it. So if you join with me this far, right? If you really want to pick this language, right? I'm just saying, right? Like for my time is it's 11:50, right? For Sri Lanka, I think it's around 10, right? It's around 9, right? So let's say it's a 9, right? And then if you have a dinner, or maybe you don't want to have dinner, right? Just read this exam, clone this repo, right? Again, it's on my GitLab, right? Clone this repo and try it by yourself. You will feel the difference, right? If you put AI, it will done it instant, right? It is done in instant, but if you try, you can just have all the instructions, right? Just simply do that with what you do, what you know, right? So get it, and then you can just uh, hold on. Open these slides, and then you can maybe open go to or you can just go for the go to or you can just go by example, right? So just using these what you learn from here, you can just go and simply do that, right? So I think I have a couple of more minutes. Uh, I can do something very simple for you guys to. This is not part of the one. Oh, standard library. Just a small note, right? So this is the Go standard library, right? This is look small, and then Go standard library has pretty much anything you want, right? Logger, right? Like database drivers, loggers, HTTP servers, right? Everything. You don't even need install any single package. You can just solely rely on the standard library, right? One of the key selling point of the Go is the standard library. If you can Google and find more if you want, right? This is side note. Just Go is the one which has excellent standard library. Because if you know, like the physical JavaScript don't have standard library. JavaScript don't have standard library, right? This one has a standard library, right? And then do, right? So just side note, right? You can just undo, right? So just go and see, right? And then try this one, right? So if you guys can, if you guys can have want to leave, you guys can leave, right? This is all the folder. We have all the folder examples here in here. This side note. So if you guys want to guys can leave, right? This one has all the Go code which I use, range, pointers, structures, variables, zero values, right? This one, all the code examples are here, right? You can just read if you guys want, right? And then uh, I can do some fun activities. This is not the part of, like you guys can, after you can guys go, right? I can just simply, I can just Kubernetes, Kubernetes, you can just GitHub, right? So, so I'm just going to go for the Kubernetes repository in GitHub, right? And then I will pick something random, right? This is really unplanned. I don't know if it will work or not. Then just go trust about maybe ports. This is just a post. Is there anything you can just control play? Control. So we can go for API, sir. So I want a big code. I want a big code. Okay. 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 Fine. This is a part of the code. If you guys want to leave, you guys can leave, right? I don't asking you guys to stay, right? I'm doing this part just to prove my point, right? Just to prove my point that I don't accept you guys to stay, right? Can I edit? Okay, yes, I can edit, right? Yeah, hold on, we don't want, right? So I just started from here, right? Basically, import. This is import, right? You can just put some alias. This is sometimes also alias like just fancy names or something you can call a fancy name. This is the import path, right? Nothing fancy, just alias and import path, right? Can I scroll down? No, I can't. Just that, okay, right? And then in here, this is the structure. This is a structure, right? This is a basic structure. I talked with you guys. This is basic structure, right? That's it, right? Ah, right? And then this is just a function, right? This is just a function, just return the controller structure. Right? This is the structure controller, and this is function return the controller. And they did it just fast. They call the informers dot function. They call that function, right? And then this is the structure. And this is the structure. The controller structure. You can see this is a controller structure, and then set in the values which is got from the function parameters, right? And then return it, right? So in here, this is belongs to the channel. This is a channel. I skip that part for you guys. This is a channel, right? Just simple structure embedding as you guys as I show you, right? That's it. Just call the function. This is the buffer keyword. You can just learn it later, right? So this is also the we use mostly for the concurrency buffer, right? Just a small function and then just check it's a true, right? This is just a for loop. This is just a for loop. Calling a function, check-in error, right? In here, just basically simply check-in error. You're basing a check-in error, right? And then the logger put the logger. For loop, the continue keyword, you guys know. Continue keyword, right? This is check is that error is check is that error is this type, right? And then the continue. That's it, right? I can what do we have? This is again structure. Start function. Just start the embed this structure to the control. Set the values. You can just see this structure. Set values for the functions. Call with call functions. Set values to the field. Just call functions. This is belong to the go routines. Go routine again, right? Check the if condition, right? Get the error here. These functions only return the error. Get the error here. Check the error. Log the error. Right? This is the go routine again. That's it. Check the error. This function get the error, right? Function. Check is that is error. Is that is error, right? Check check is that error is nil. Right? This is another function code. Right? That's it, right? This is the switch case. This is just a switch case. The switch case with some and equal is nil and then equal and then equal is right? So the my point is right. This is the 80% of what to learn. And I skip the go routines, right? I skip you guys for the go routines, right? You guys can learn it later. Go routines. It's on my site. Go routines. Differ keyword channels, right? So these are the only part I skip for this session. You can just this is because out of the country, you can just go and study more, right? So this only I skip, right? So this is just Kubernetes, right? This is just Kubernetes, right? This is just Kubernetes code, but just real code. This is not something I planned or anything, or I just tried to, This is just Kubernetes. You can, with what you learn today, you can just go and open your slides from one side, right? Your slide from one side, and open the Kubernetes code from one side, and try to read the code, the Kubernetes code, right? And then you will see what's the difference. You can read this code and try to understand this code, right? Maybe if you can't understand just because if you don't have a context at what actually it does, but you can read the code and get what is it do, right? With what I teach you, right? This is it. This is the killer feature of the Go. You can simply just one night you can just read just get the code, just jump into the keyword and then explain it, right? How to define the things, just simple spec, just understand it. And then you can just read pretty much any Go code, right? Unlike Java, you don't have like annotations, variables, recording, Like you don't have to do all the gymnastics to just to understand the Go code, right? So so just I just want to just prove, right? You can simply read pretty much any Go code with just what you learn. I mean, just what you don't learn. That mean like that's it. That's what all you have to learn. That's it, right? So I will go and annotation now. Right? Go back, right? So just basically these things. That's it, right? Just basically how many. So they said just 400, right? So the 400 lines, right? This 400 markdown file, and there is some all the code examples, simple code examples. We have the Go routines and everything here, right? You can study, right? So this whole thing, is whole language. You can just read pretty much any code, right? Okay, I think I have 4 more minutes, right? I can just what is you can just git up Ethereum. This is Ethereum code base. So I can go and random. This is Ethereum code base. But we can try. Basically, what we learn. I'm not joking. This is what we learn, right? This is what we learn. Like nothing fancy. Just if for loops, we check the length. We use length keyword for the check the length of the array. We use the length keyword because we don't have dot length. Uh, where we have this is generics. This is part is generic part. But even if it's generic, just you can read the code, right? Right? This is just a code we learned today, right? That's it, right? Just this variable declaration, for loop, function call, return, right? This is it, right? So this is just code what we learn, right? So I think that's all right, because I took up more than I think around more than 1 hour, right? So I think that's all from my side, right? And then I think can wrap up today, right? For session. So yes, so thank you so much, and then and over to back to the first side, right? So yeah, thanks for your
Yeah, thank you so much, Mr. Sithum, for that insightful and engaging session. I'm sure everyone found it really valuable and learned something new about Go. Now we'll move on to the Q&A session. If you have any questions, feel free to drop them in the chat or you can unmute yourselves and ask the question. We'll give you a few minutes for the questions. Come on, guys, you can ask anything and get your doubts clarified.
no reactions, right? That's good,
Yeah, so
right? Good, right? Like
I'll
classic,
ask a
classic,
question.
classic sleep fever. Okay.
Yeah, I'll ask a question. So, Mr.
Okay.
Sithum,
So,
what would you recommend as the best way for beginners to start practicing Go after today's session? Shall I
okay.
repeat?
Yeah, sure. So if you guys want the like you can just go and like you guys can try I give a basic example for you guys for the session for the to-do app. You guys can try it, right? If not, right, you maybe have, I don't know, you maybe have assignment, you maybe have a company project, you have a company internal project, whatever, right? Just try to build something with the Go, right? So like I don't I don't try to like you guys like say not to use AI or anything, right? It's up to you guys to decide use AI or whatever, right? You guys just go and then see and then like try to build something by your own. So that's what you should do, right? It doesn't matter like if you follow my one or whatever. You may join next one, as I said, try to. So the main point is try to practice. Right? Practice again and again and again. Right? All you have to do is the practice. That's it. Just just build something simply. That's it. That is cool.
Thank you, Mr. Sithum. You have some more questions in the chat.
Okay. 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 Go routines and okay. Just want to know how to open the slides, right? So okay. So the slides. How do I say? Okay. Let's do. Let's do something. Right? For the slides, I will do something like this for you guys, right? Then simply cd this clone the repo. Then just simply pause. Right? Then just go to the cd person. Right? And you can just simply go there, enter. It will take a couple of minutes. I don't know. You can just run it. I already running. Okay. Boom. That's it. Right? That's it. For the go routines, I think I have a slide regarding that. Uh, go routines. So this is the go routines, right? So it's simple way if you have any experience with the threads, multi-threading, right? Basically, is just provisioning new multi-thread, right? That's it. It's a channels and monitoring. So I will give you a quick thing, right? If you want to learn, just go for the go by example. We should have a go routines here for array, map, size, enum. We have a channels. We have go routines here. Right? This is that's it, right? I can. I think this will be effective better than I'm telling you guys orally. Let's just then channels here. So this one will tell you what's the channels, how it works, right? And you can just read it and practice. As I said to you guys again, read it and practice, read it and practice, right? This is it, right? It just another function. You put a go keyword in front of it. You are calling function, but you put a go keyword in front. This is the normal function call. You put a go keyword in front of the function. Right? That's it. You can read and you can understand. We have a weight groups, some other keyword as well, which comes from that. It should something you should study separately. You have channels. What else we have? We have channel buffering, channel directions. We should have a weight group as well. We have weight groups, worker pools, worker pool, right? Right. This is like we have a like. So you can go from the right. Go on currency pattern. This is from the original Google. There are some so much things you can just try and learn. Right. Right. I just you can just basically search on YouTube. Right? Go on currency pattern. Right. What else? Okay. So you ask like, what's the best beginner budget starting with the Go? I don't know. Right. I don't know. I don't know what's best for you. I I don't know. I don't know what's the best for you. Right. But you are the one who know what's best for you. Right. Not me. Right. So what's project interesting to me is not whatever. So basically, whatever project, right, which like whatever project which you passionate about, right? The whatever project you got stop thinking about, right? Whatever project make you to wake up this whole night and then just put yourself to do it. I don't say like this could be this, right? Just whatever project make you to keep you up the whole night to just to do it. Just you to make sure the fancy thing, right? It could be a to-do app, it could be a weather app, it could be AI automation thing, right? Whatever is I don't know. Maybe you can try to read someone else code. You can just try to read someone else code, try to read understand it, right? So you maybe you have something written in Python or Java or something, you can just want to make it, right? Or you are working on maybe you are working on a company and then you already work on the company, you already work inside and then you want to try the same thing in the Go and see how it's work, right? Something like that, right? I don't know. Can just it's something which you are passionate about, which you like, right? Okay. I think I answered the for the questions. We put a poll right here. And so we have mostly students write Java or using JavaScript. Okay. Okay. I can do something simple for you guys. What I can do. Like you can just Google popular Java project. We have a Apache Kafka. So just Vita. I I don't know. Oh my god, so many files. So we can just simply oh XRC and okay, traditional Java. So, oh, just I mean I'm not joking, guys, right? I'm not joking, right? This is a popular one Java. Look at the long name, right? To go for the Kubernetes, and what is the reader, right? And then like you can see like what is this gibberish, right? The long name of the method, right? And then look, right? Is stream, set, set, right? Hash set, right? I don't know, like if you guys ever try to like for each, what is this? Then just I don't know, like who defined method like this? It's just so right? New. It's like there should be some funny code. Override, override, right? Public boolean is statistic. Public. Okay, we have a public cast, and then we have a public statistic final, right? And then whatever, like we have override, uh, new. And the thing is, my point is, right? You can basically read and understand the Go code out of the box. Like no factory is nothing. Then just read and basically understand the Go code. Right? Like basically you don't have to like array to return things. I don't like you can just check anything, right? Like what is this? Right? Like optional plugin authorizers, right? And then it's what is optional dot empty. So we don't have those kind of problems. Then just simply go and read and understand. Like we in Go, we don't have like this kind of long, ugly method inside, right? So I just simply saying this, right? Like a throw new, don't have those. Okay, okay. Anyway, any other questions? Yes, I have anything.
I think that's all.
Okay, okay. Go,
Yeah,
like,
so all right, if there are no more questions, we'll wrap up today's session. Once again, a big thank you to Mr. Sithum Bopitiya for sharing his knowledge with us today. And thank you everyone who joined and actively participated. We hope to see you in more sessions organized by Slate First Community. Have a great evening, everyone. Stay safe and keep learning.